Okay, good morning, everybody. So today we are going to go over, we're going to actually start in a chapter one, section four. And this is going to be the first of a couple of videos that I'm going to make for that chapter and section. And the reason we are going into that is it's going to be more of the solving various quadratic equations. So in the P4 chapter and section, we discussed a few different factoring techniques. And then we are going to use those and more factoring techniques to allow us to solve, for right now, quadratics. Eventually, we're going to be solving more involved polynomials than just quadratics. But for now, we're going to start with quadratics. So let's get started here. So there's a few different things we're going to do. The first thing we're going to do is solve quadratic equations by factoring. So as an overview of what a quadratic equation is, a quadratic equation in X is an equation that can be written in and they say general form, and this is a point that I want to make sure that I reach out to you guys and make, is that this book and these slides call ax squared plus bx plus c equals 0 general form. Now, last year and even this year, what you'll hear me refer to this form, this is actually called standard form. This is very important, though, for you to understand that when you see in the directions it tells you to write a quadratic equation in general form, they actually mean standard form. I don't know why this book refers to this as general form. It is literally the only book that I've ever seen that does refer to this as general form. Everywhere else that I've ever seen, whether it be whenever I was in high school or any the studying that I've done, refers to this as standard form. So you will hear me call this standard form, but just be aware that in the directions, if they say put something in general form, this is what they mean. So this is considered a second degree polynomial equation. And the reason why it's a second degree is because it's got an x squared. So we're going to actually learn four methods for solving these equations in here. We're going to learn about factoring, which you probably did a little bit last year. We're going to learn about extracting square roots. That's pretty simple. Actually, I'm going to show you those two today. We're also going to learn about completing the square. Unless you took Honors Algebra 2 last year, you will not know how to do that. That will be new. The quadratic formula, I think you guys covered that last year as well. I'm probably going to use a little bit more and explain a little bit more in depth than what it was explained to you before. But those are going to be four ways that I teach you how to solve a quadratic equation. So the first method is going to be based on the zero factor property. And what the zero factor property says is if you have two different things, and you can see there's an A right here and there's a B, and if those two things multiply to give you 0, that means either A is 0 or B is 0. And so in layman's terms, that means if two things multiply and give you 0, one or the other has to be 0. That is the only way to get 0 when you multiply. One of the two things that is being multiplied is 0. Now, we're going to use that fact when we go to try to solve something like this. 2x squared plus 9x plus 7 equals 3. The first thing that you need to see is that this is not in standard form. And again, the book calls that general form. But this is not in standard form because there is a 3 right there. And in order for this to be in standard form, all the stuff has to be moved over to one side of the equal sign. So that is exactly what we're going to do. We are going to subtract 3 from both sides. And when I subtract 3 here and I subtract 3 here, you can see that I get this new equation that is in standard form. Now, what we do with that equation is going to be based on our work from last chapter, the prerequisite chapter, and we need to break this up. We need to factor it. In order to factor it, we are going to need to use the ABC method because there is a lead coefficient of 2. And so the ABC method says we multiply the 2 and the 4, and then we get 8. Okay? We need to write the factors of 8 out. So we have 1 and 8 and 2 and 4. And we need to pick the pair that add up to be 9. And so I think it's pretty obvious to see that this 1 and 8 are going to be the two that we use. Now, this slide, as we work down through here, is missing some of the steps, which is what I'm filling in as I'm writing. So we need to split this center term now. And so the new equation is going to be 2x squared plus 1x plus 8x plus 4 equals 0. Now that we have the center term split, we are going to group the first two terms. We are going to group the second two terms and take the GCF out of each of those. So the GCF for the first one is an x. The GCF for the second one is a 4. And you can see that when I do factor out the GCF, I end up with 2x plus 1 in both of those parts that are left over. And that's good because in order to proceed to the next step, you need to have 2x plus 1 in both of those steps. So from there, we rewrite one of the 2x plus 1s, and then we regroup the GCFs that we pulled out, the x plus 4s. Now here, so all of that we've covered in the last chapter and section in the prerequisite. Here's what the new step is. The new step is that we now have this equal to 0. And so our goal is to solve this to determine what x values will make this equation equal to 0. So looking up here in the original equation, we would want to find what x values you could plug in there to equal 3. So we first moved the 3 over, then we factored. The last thing is where that zero product property comes into play. The zero product property tells us that if you have something times something else and it equals 0, that one or the other or both have to be 0. So we're going to simply set 2x plus 1 equal to 0, and then we're going to set x plus 4 equal to 0. And we are going to proceed to solve those. This particular one, we would subtract 1 from both sides. We would get 2x equals -1. And then once we divide both sides by 2, you can see x is -1/2. This second part, you would subtract 4 from both sides, and you would end up with x equals -4. And so if you wanted to check that these were the solutions, you could take each one of these x values and you could plug them back into the original equation where x is, and you should get that equation equal to 3, as you see over here. I'm not going to do that, but that's how you would check it. So here's another example, solving. This one's a little different than the last one, and this is why you hear me talk about in the prerequisite chapters that you have different techniques, different factoring techniques, and that we need to be fluent and knowledgeable of all of those techniques because every equation is going to be different. In this case, you can see that we have a new equation that is already in standard form, or as the book says, general form. But looking if we would line this up with standard form, you can see that we are missing the c value. There is no c right here. B is -3, A is 6. So when we are missing the c value, when we're missing that c value, the technique that we use to solve this is different than what we used in the last one. In the last one, we had to put it in standard form, and once we did, we had all 3 terms. So we had to use the ABC method because the lead coefficient was 2. Okay? In this one, we are missing the c value. The c value is 0. So this one is solved differently. And as you heard me say before, the very first thing that you should always try, even though I didn't mention it in the last one, the very first thing you should always try is to take out a GCF. And if you look at the 6x squared followed by the 3x, you can see that they have a GCF of 3x. So when I take that 3x out, I'm left with 2x minus 1. To verify that this was indeed done correctly, you could redistribute the 3x like that, and it would give you 6x squared minus 3x equals 0. Now from there, you need to take the 3x and you set it equal to 0, and then you take the 2x minus 1 and you set that equal to 0 as well. And so as we do that, you can see that 3x equals 0. I divide both sides by 3. I still get x equals 0. This one, I'm going to add 1 to both sides, and I get 2x equals 1. And then I divide by 2, and I get x equals 1/2. And so we got two, again, the same as the last one, we've got two solutions. Both of those x values will, if they were plugged back into the original equation, would give me 0, which is what we were looking for. Now it says the zero factor property applies only to equations written in general form in which the right side of the equation is 0. And so what they're referring to is back here in this original one, we couldn't just take this and factor it, right? So we had to move the 3 to the other side and get the equation equal to 0 before we could proceed to factor and then ultimately solve. And that's important to remember, that you have to get this thing in standard form, or as the book says, again, they're calling it general form, but it needs to be in standard form first before you can solve them. Now, the second technique, the solving technique I'm going to show you today, is what they call extracting the square root. It's actually really simple. It doesn't involve factoring at all. It just involves moving everything away from the variable as you have been taught since you've been solving 1- and 2-step equations. So if you look in this first example here, I have 4x squared equals 12. The first step to that equation is going to be to divide this by 4 and divide this by 4. When I do that, the 4's cancel, and I'm left with x squared equals 3. Now, the next step is we need to get rid of this squared right here. In order to get rid of a square, the inverse operation of squaring is square rooting. So we need to square root both sides of the equation. And something to keep in mind is when you square root, that cancels out the square. We're simply left with x. But on the right-hand side, you can see that we have included this plus or minus. The plus or minus needs to be included because this equation has two solutions. And as a side note, if you were to graph this equation, you would see that it crosses the x-axis in two places. So we need to make sure we account for both of those solutions. And in order to account for both of those solutions, when you take the square root of both sides of an equation, you need to make sure that you include the plus and minus sign. Now, looking at part B, actually, let me finish right here. So that plus or minus means there are two solutions, the positive square root of 3 and the negative square root of 3. Both of those answers, if plugged back in here for x up top, would give you the result of 12. So now this one is pretty much the same. We have a little bit of different order of what we're going to do to undo the stuff that's happening to the variable. But as you can see to this x variable, it's being subtracted by 3 and it's also being squared. So we need to undo both of those. The first thing we're going to undo is we're going to start with the square. So we're going to square root this side and we're going to square root this side. And when I do that, you will see that I'm not quite sure. There it goes. It just popped up. The square root cancels the square. And on the right-hand side, we need to include the plus or minus. So we ended up with x minus 3 equals plus or minus 7. The last step to that is to add 3 to both sides. And when I do that, I end up with 3 plus or minus root 7. You do not need to give me a decimal answer. You don't even need to split that up. That is the final answer for x, and you can leave your answer written like that. The 3 and the square root of 7 will not combine. So that's what I got for you today. Hopefully both of those examples that I showed you, both techniques of examples that I showed you make sense. And as always, if you have any questions, please feel free to reach out and email me. Have a great day.